So next up is Ben Stamnes and Anders Lassen from Outracks.
Hello. Wow, we feel so welcome. Thank you. Thank you. Oh, no, it's too much. Sorry. Oh. All the way from cold Norway to hot Helsinki, actually. So that's quite nice. We are from Outracks. We're going to talk a little bit about real-time graphics, because that's the cool thing. Everybody loves that, including us. So let's just kick it off, shall we?
Yeah.
We are basically a company from Norway, based in Trondheim, a little bit in Oslo. All demo sceners from various platforms. I mean, everything from Atari 2600 to the PC, Amiga, Commodore. Everybody has worked in real-time graphics in some other way, and then decided to just combine forces and just go, let's see if we can make a company out of this, because we feel that we have something that the world needs, I guess. Let's see if that's correct. Mm-hmm. So the story about real-time graphics is, everybody probably knows this lovely little machine, which is a really, really, really bad piece of hardware. Basically, you couldn't do anything. So one of the guys we hired decided that he wanted to make a 3D rotating cube for it.
So let's have a look at what games on this machine actually look like.
Yeah, this is what games look like. I mean, come on, this is terrible. Mm. And this is now how old? 35
years old.
35 years old. So this guy we hired decided that he wanted to make an example of this. So let's get a 3D rotating cube on it, just to prove a point. Like, even this, which can't fit a tweet in its system memory, we can still make a rotating cube, and he did. And this is what it looks like, if you can get it on the other.
I can't get it on the other screen.
You can't move the...
No, the mouse cursor is disabled.
That's
in
what
the
it looks like. This is very high tech. But the point just stands to say that everything has had real-time graphics. Since the dawn of time in computers, everything has had real-time graphics. And
yeah, we've had real-time graphics, 3D graphics capable machines since 1977.
Yeah, you should pull your mic a little closer too. So this just shows that graphics have been with us since the beginning, doing everything, and now we have these super crazy gaming rigs that you see out in the hall that everybody used to play games with, the same games that we used to play 10 years ago, just prettier, than the same games we used to play 20 years ago, just very much prettier. But making stuff for these things has always been sort of an expert's game. Maybe you were to the previous seminar, you listened our approach is to standard make your own custom C++ engine or something for this. And that's the thing, if you have 2 months on a gig, that's actually quite hard, especially when the clients keep changing their requirements from fish to trees to back to trees and God knows what.
First, a little bit about our vision, because we have all these capabilities now. We have brick-sized GPUs that can do amazing things. Just look at the latest computer games, and you see what is actually possible with these machines.
This is just some of the examples, everything that we find.
Why can't we do all this cool stuff in more contexts? Why is it only reserved for cases where you can afford to have expert programmers coding on it for months?
Yeah. And this is pretty much what we want to do, but we couldn't put real-time all the things on the business cards. That would be stupid. So we didn't. So we're just using it on a slide instead. But this is pretty much it. This is the status quo that we want to see, when we can do real-time for everything. And when you look at AAA games that ship on the PlayStation 3 and the Xbox now, where they're using Flash engines for their UI, my mind goes, boop. It's crazy. I don't want to do that. I don't want to do that anymore. So in terms of what we can do and can't do, it hasn't really changed much. We can do it, but it's expensive. It's time-consuming. We have to hire the best people all the time. That's expensive.
And I know you, Bent. You want to create all the things.
I want to create all the things. I make demos, but I don't code anymore. I haven't coded for 20 years. So what I do is usually just tell a coder, when he's sober. I want a thingamajig that I can rotate, and then I want the spike balls and the thing, and you just leave me the controls. Thank you, bye-bye, see you in 2 days. And then the demo comes out. And that's possible because he's really good, so he can just make the, well, you don't have to be good to make a spice ball, but you can make pretty cool things and just give me the controls, and I want to do that. My next logical step is to make the thing in the beginning myself. And I'm not a programmer. I don't know what object-oriented programming is. It annoys me. There's no variable. It doesn't make sense to me. So I don't want to do that. I want to make something myself. And I think visually and not in code. So
that's the thing. So although we have all these machines that can do all these things, it's just really hard to do it still. You still need expert graphics programmers. You still need, even if they're experts, it still takes months or years to create even things that sound really simple on paper, and that we have seen many times before. That the technology is there.
Yeah.
These things have been made, but it's really expensive and difficult to do it again, like with different content, for example.
Yeah, and that's also the thing. Like it was touched on a little bit with in terms of reusability. There is really no such thing in terms of computer graphics. You often remake your own particle engine 15 times. This is not rocket science. Everybody knows that this is happening.
Can you get a hand in the air from anyone who's a coder or tried graphics programming out there? So that's more than half of you. So how many times have you, if you've done shaders, like how many times have you written a lighting shader?
Or an object loader.
Yeah. You end up writing the same things over and over again. Like it's really hard to. Every time you want to make something, it's always a lot of work, no matter what it is.
Yeah, so this ought to be no surprise to anyone. Not only do we have real-time graphics everywhere, but we no longer have software shading. We have GPUs everywhere, in the phones. In your refrigerator has a phone. If you have a Philips refrigerator, it has not a phone, GPU. You can build anything for it, but it's really hard again. And with the GPUs comes another set of abstractions and layers and APIs that you have to deal with. And if you want to go multi-platform, well, that's a whole other. I mean, that's why these guys are doing everything in WebGL now, I guess. One platform. So that becomes a nightmare, and we don't want to deal with that either. Yeah,
because I think this is a big paradox, because I have more computing power than the entire world had 20 years ago in my computer at home. But that doesn't, this is my apartment and this is my GPU. But adding these two together does not make my living room look like the Avatar movie, although it's perfectly possible in technical terms. It's just, there's something here blocking us from achieving all these wonderful things. And this is why.
Yeah. Like we touched on this, like the GPUs themselves are complex. You have multiple vendors, you have multiple APIs, and they keep going. They keep getting longer and longer shading pipelines and everything that you have to do, and you have to have new conditioning tools and new engines, and then you have to upgrade your engines, and then you have to upgrade your assets. If you make games, you know this scenario very well. And you have QA, which comes into play if you want to ship like a AAA title game. That becomes a problem because you have to test everything everywhere. And if you ever worked on Android, which I do on a daily basis, you know, it's not a good place to be. Very hard. Don't need to stress this point enough. Everybody knows. And you have the fragmentation both in, you know, APIs and types and vendors and languages.
So a solution becomes outdated really quickly. Like if you made an engine last year, you probably learned a lot from writing it, and the GPUs have evolved, the best practices have evolved, the platform you want to target has changed. And so this is what is preventing reuse and efficiency. Yeah,
and then you start the next project thinking, I'm not going to make the same mistake I did the last time, and then you do. Or you make another mistake, which is more expensive.
There is a lot of cool graphics stuff out there on the net, and in games, and in demos, and in the stuff that we just saw these guys making. But
but the problem is that reuse is, if not impossible, then extremely limited. If you're talking about a static geometry or a simple texture, then yes, you can reuse that somewhere. But if you move it from a high-end console or high-end PC out to the web, you probably have to do something with it anyway.
For example, you can go to nvidia.com and download this hair demo. It's basically a really cool hair rendering effect on a head, and you can shake it around and watch the hair blow and so forth. But then what? Because there is no easy way for me or you or anyone else here to take that effect and put it into my project, into my app, into my website, into my whatever it is I'm working on. Because although you have all the code there, you have everything up there, it's up and running on your machine can obviously do this, then you still need to be the programmer's equivalent of a brain surgeon to go in there, take the shader out, take all the plumbing out, all the API calls, and move that over to the new context.
Anyone who's worked with this noticed that a shader is not just a file in a directory, it lives with the rest of your program. So you can't just take it out and put it in somewhere else, usually, unless it's very, very simple.
And then we realized that there is actually no exchange format for real-time graphics. Like, if I have some real-time graphics over here, how do I give it to any of you guys? I would probably upload a full project with all my source code and all my base code and everything, so that you will have to comply to my coding standard, use my standard library and everything just in order to run it.
Yep. And this is also, for those keeping tabs, a bad thing.
And there's no tool out there that I know of where I go to when I want to do real-time graphics. Well, you could say you have Flash.
Yeah. Yeah, I mean, there are tools and engines and packages that allow you to do it. You can do it in Flash, but then again, what are you going to do? What are you going to make? Does Flash necessarily mean that you're going to hit the platform you want to hit, at the frame rate you want to hit?
In the number of dimensions you want?
Go 3D and everything goes boom. No, usually not.
And so the biggest problem at the end of the day is that creating real-time graphics is in the domain of coders, not artists. Like, artists really want to get in there, but they have to work through coders, which is often very frustrating.
So they become, backseat coders that just sit behind the guy and go, no, back to use that seat, that was prettier. And that's not very efficient.
Okay, so now we've been ranting for 10 minutes about how bad everything is.
Yes.
So now we're going to switch over to a bit more technical discussion for another 10 or 15 minutes before we show a demo of what we're actually doing to make the world better. Yep. The question we asked when we tried to find out, like, okay, everything is painful when it comes to real-time graphics. It's really cool to work with real-time graphics. I love doing it, and there's a lot of things I would like to make. I would like to make games. I would like to make interactive clubs like these guys did. I would like to make 3D websites, 3D advertisings, and all these things. But it's hard, and I realized that at the current rate of things, the current state of the art, I would never be able to do all the things I want to do. So we started to analyze. What is real-time graphics? What's the nature of it? In what format does it exist? Well, the way I see it, real-time graphics is your code and your data set. And the data is typically your 3D models, your textures, your sounds, your sync data, whatever, and it goes into your code and magic happens. But and that's also why real-time graphics is difficult to exchange, because there is code and data sets like working together in a specific and very fragile way. So one simplification that we made, which is valid, is that you can look at data as code. If you're coders, you have probably found yourself writing like huge CPP files full of some data in some structure, like full of bytes or words or whatever. So we could make the simplification to say that real-time graphics is, if we're going to exchange it with each other, send it to each other, upload it, make it open source, give it away, or whatever, the exchange format has to be code. There has been several attempts by many people and the industry in general to create data-based formats for exchanging graphics, like Collada. Who here have tried Collada? Who here think it's great and solves all their problems? So, when we've made the simplification that real-time graphics is code, then an exchange format for real-time graphics would have to be a programming language. But which programming language are we going to use? Can't we just agree once and for all that we're going to use one specific language to exchange real-time graphics? Any suggestions? JavaScript. Yeah, that's the closest thing we have. What about ActionScript? C#, C++, render script. What about the shaders? What are we going to do with those? What language are we exchanging those in? Now the thing is, there is no such language. So we set out on the mission to create it. We wanted to create the language that everyone can use to exchange real-time graphics, effects, games, apps, utilities, so that everyone else, even if they're not programmers, can just drag and drop like you put a button on a form in Visual Basic. You put a cube in a scene and you put an effect on top of it, and you put it out on the platform you want it on. That's what we wanted to make. Unfortunately, this is madness. So we sat down we've been working on this since, actually working on solving the general problem for many, many years, but this particular solution for about 3 to 4 years. So this is how we're thinking. This is our strategy for designing a language for real-time graphics in 2012. Point 1 is that we're not going to reinvent the wheel, but there is a missing wheel on the car, and that's what we're going to put there. But we're going to use all the good pieces. Like C++ is good, JavaScript is good, C# is good, DirectX is excellent. Even WebGL is proving to be pretty decent. Even Flash, although it's not my favorite, it's something that works, and it's out there and it's established. But we're going to make a proper language. We're not making yet another engine of some sort. Like, people have tried to solve the problem of efficient production of graphics content through engines and frameworks since the 80s. But we're not going to do that. We need to take a completely different approach if we're going to change something. And we're making the language general purpose, so it can actually be used for all the things, not just games, not just ads or flash games for Facebook. We want to make something general purpose that you can use for all your graphics needs. So we're making no assumption about what you're making. And we kept in the back of our heads that code is not the goal. Like, graphics is the goal. But code is the way that we represent graphics. So the language should, at its most crucial function, is to work as the infrastructure for content creation tools. Like, imagine if you were sitting in Maya and making a scene with lots of effects and things going on, and what actually happened inside Maya was that it created the program for you that would produce that real-time graphics effect. Imagine if it did that. And our end user is not a programmer. Fine, we want programmers too, should be able to use this, but we also want to make real-time graphics available to those that cannot write code, like my mother. She needs to be able to put fancy 3D pie charts in her PowerPoint presentations. Today she can't. Yeah, anyone should be able to reuse, combine, and tweak existing effects and assets without knowing how they work on the inside. So take that here effect, for example, from NVIDIA. I don't know how it works, but I should be able to just drag and drop it onto whatever there is I'm working on, because it's there, the technology is there. I just saw it running on my computer. My computer can do this. So why can't I do this? We found out that one of the biggest blockers from creating reusable and exchangeable graphics components is that graphics effects are a combination of all these things. Like, you have data set, like your models and textures. You have your shading code that runs on the GPU. You have maybe some compute code that runs on the GPU as well, and some CPU logic, and there is a lot of plumbing there. like get that value in there and that value back from there, and that buffer is going to bleeding over in that buffer. We need a unified representation for all of this. So we're merging them all into one common representation. And then we let a compiler or a translator do the dirty work of going from that one representation and back into what the computer actually needs to run this. So you write your graphics effect in this one single representation, and a compiler comes in here and does all the hard work of optimizing it and tuning it for the target platform. And out comes code for the CPU, code for the GPU, optimized data set, and shaders and compute kernels and so forth. So meet the language we call Uno. This is the current graphics programming paradigm. Do anyone recognize this? It's all the languages you have. The list is actually much longer. If you want to make an app that runs on Android, iOS, Windows Phone, and in the browser maybe, and maybe in Flash as well, you need to write that app in a ton of different programming languages that use a ton of different graphics APIs and a ton of different shading languages, but they all map down to the same hardware. It's the same CPU, and graphics APIs is actually the thing that is most common or similar between platforms out of anything. So the Uno paradigm looks like that instead. So yeah, we made a programming language. What does it look like? Uno in a nutshell, it's strongly typed, it's object-oriented, it's garbage collected, and its most distinguishing feature is that it has knowledge of the GPU and knowledge of real-time graphics built into the language. The compiler knows that you're doing graphics. It knows there's a CPU, there's a GPU, and there's a lot of plumbing going on in between there. So it's trying to take as much of that plumbing off your hands so you can focus on expressing exactly what you want to appear on the screen. It supports something that is very important that JavaScript doesn't have, which is user-defined value types. That's structs in C#. That's little pods of data that is just data. They're not objects. They're not fragmented around in memory. So you can actually build buffers of small data types. This is really important when it comes to performance. It supports generics. So you can have a dictionary of the keys and values and lists and all these fancy things that we're used to from languages like C# and C++, and to some extent from Java. And if you're a Java programmer, C++ programmer, C# programmer, you will immediately recognize what's going on here. And the language is also designed ground up for being translatable, source-to-source translation. We're not generating native code. That's a solved problem. We use existing mature compilers for that. So finally, we have a compiler that knows graphics. That means you can have reusability. You can have combinability. So if you have two effects, like I have a car and I have a particle engine, then I can put the car inside a particle engine, and it should, in theory, just work like this. And the compiler also knows the best practices. It knows what texture compression formats to use. It knows what kind of vertex cache size the target device has, so it can pre-process your data set and everything. And the reason it can do that is because this is an all-seeing compiler. Regular compilers see one processor. They see either the CPU or the GPU and generate code for that. While Uno sees your CPU code, your GPU code, and your data set. So the Uno compiler can do things like constant folding from your shaders all the way back into your data set. Oh, you're multiplying by a constant matrix. We're going to fold that into your vertex buffer, and then pack your vertex buffers into PNG that JavaScript can load. The compiler can do all these things because it sees everything. Uno is also minimalistic. The traditional approach is to have a big runtime engine, like Unity or JavaScript engines like 3JS, and you build your application as a thin layer on top of the big engine. While in Uno, there's just your application, because the compiler takes the role of the engine. And what comes out in the other end is code that does specifically what you ask for. If you put a cube in a scene, then you get the cube. The code that draws the cube, nothing else. No loaders, you don't have to ship the entire Collada library with there. You get exactly what you ask for. So the minimal export from Uno is a few kilobytes. You just pay in bytes for what you're actually using. If you're using physics, well, then we have to link in the physics engine. If you're not using it, it won't be there. This makes Uno a good replacement for Flash, for example, because you can actually make really lightweight web content like banners and Flash games and all those things that load very quickly. Yeah, but the beauty of source-to-source is that we can support all platforms if there exists a compiler for it. We just export to the native programming language of that platform, and we can benefit from the maturity of the existing compilers for that platform. So we are one source language and multiple target languages, which means Uno can go anywhere. Anywhere where there is a programming language and a graphics API, we can make a backend. So, do you believe me? Do you think this will work? I'm going to switch to a single screen now.
He's going to start coding now.
Yeah.
Maybe.
Yeah. I'm going to show you how to make... first, we're going to make a really simple application in Uno. And then we're going to show you a little bigger project that we've been working on that is running on several different platforms from the same source. And what you're seeing here is actually code from the compiler. Let's see if it's powering up. There we go. This is Realtime Studio Lite. It's a light version of the product that we will ultimately make, which is a tool built on top of Uno where you can throw around Uno components and create applications without coding. Or you can code if you prefer, but it's not required. Well, let's see, test 2. I'm going to place that on my desktop. This looks very familiar if you're familiar with like any modern IDE, and it's basically what it is. You collect files and compile them, and it runs. Can you see this, or should I make the text bigger? Let's see, how do I do that again? There we go. This should be big enough for everyone.
Famous last words.
Oh. So that's basically all you need to get something running. You inherit from Uno application. The compiler looks for a class that derives from Uno application and will instantiate that for you. Uno is always graphical. It's a language for creating the front end of your product. You don't write business logic in Uno. You do that in .NET or something proper. This is for what you see on the screen at the end user device. So if you create an application, it's going to have a window. So that's already set up for you. I can press F6 now, and it will just preview this application in the editor. So it's just an empty application with camera and stuff is part of your application object. But it's completely optional to use. So, you're going to get the first triangle on the screen. Uno is a graphics language, so of course we have all the types you know from shaders. They are readily available for you in the standard library. I'm going to actually write the triangle by hand just to show how it's done. So minus 0.5, 0.5, that's the lower left corner. I'm going to explain a bit later what the syntax actually means. Now I'm just creating a buffer of vertices. That's the right corner, and this is going to be my top vertex. And now I'm defining a drawable. There is something drawable in this class compiler. Take note. And inside my drawable, I need to specify what we call predicates. You might have noticed the colon syntax here. Colons indicate that this is a predicate, and what we mean by that is that that is code that the compiler decides if it runs on the GPU, if it runs on the CPU, if it's pre-processing code or data generation code. The compiler will decide, and if you don't say anything else, it will assume everything is constant. so it can do a lot of folding and optimization. I need to define the output from my vertex shader, which is clip position. And I compute my clip position by picking a vertex from the vertex buffer. And maybe I should zoom out a little bit. Still big enough? Yeah. So I pick a float 2 from my list of vertices and pad with a 0 and a 1. So we got all 4 components set. And that's basically, this is what I want to express. But imagine doing the same thing in OpenGL or DirectX. You would have a lot of verbosity because you're going to upload some vertex buffers, first of all, create a vertex buffers and so forth, and throw things around. And then I define the output from my pixel shader, which is going to be a lovely color. And that's all I wanted to say. I want a triangle. And this is a triangle. Next step is to create a method for drawing the drawables in my class. And you do that using the keyword expose. You expose the draw method. I'm going to name my triangle triangle here. Expose draw triangle. There we go. So now I have a method in this class to draw it. The runtime environment will call the draw function on my application class once every frame. So in order to be able to draw something, I need to override the draw method. And all I want to do is to draw my triangle. There we go. That should be enough. So Control F and F6. I got 2 errors. Clip position required but not found. Postion. And here we have a triangle. And the cool thing is, this is now running in, Uno code is compiled to .NET bytecode, running inside Realtime Studio. But let's say I want to have it somewhere else. I have this nice little menu here. So I can power up Chrome, because you have to do that when running files locally, because otherwise Chrome can't access your files. And I export, and there it is in the browser. Now it's exported as HTML5 and JavaScript. And you can export to your cell phone, like iOS, Android, and we're working on several other backends, for example, for DirectX and for Windows Phone. So this is how you do it now. And this code it doesn't use OpenGL at all. There is no graphics API calls here at all. It's all built into the language. Let's have a look at a little more complex project.
You don't think they're impressed yet? That's not enough? Pink triangle?
Pink triangle should be enough. But just to make sure, here's a game. This is a first-person shooter written in pure Uno. And I'm going to press F6. And it will now compile. It's a 400 megabyte data set here, so this is going to take a little while. Generates a couple of hundred shaders, spitting out a few hundred .NET classes. And now it's loading. We should get a loading bar.
Yeah. It's just a demo, right?
Huh? Yep. So here we go. Game is now previewing, but it's loading a bit too. This is a game where you fight mech aliens from space. It's a first-person shooter. This is just the intro animation.
So this now runs locally on the on
in
Windows.
the .NET VM.
It took him a long while to write code to color all of those triangles green, by the way.
And you can press play and start shooting. Let's turn on some sound as well. If I have sound. So you see we have several effects here. You saw the helicopter is doing some frame buffer distortion, so are these bullets. All the aliens are throwing shadows. And I can go down on the ground and go after them. So that's cool. Next step is I want to have this game on the web, so I'm gonna make a WebGL version of it. That's gonna take a while to load, but it'll eventually it will run. And guess what? This also runs on my cell phone. It's exactly the same code base.
I don't think we have a camera, but
no.
we can actually show it to you afterwards if we want to.
We'll pass it around.
Yep. So this is.
You can actually sit here and.
Yeah, there you go.
And preview your code, and it will. The iterations are quite fast because all your textures are kept in memory between recompiles, because you don't explicitly load textures from your code. So when I make a little change to my program, I can just hit F6 and it will refresh in half a second or something. And here's the game running in 60 FPS. No, not 60, 30 FPS.
30. Don't get ahead of yourself.
But in 16x anti-aliasing.
That's true.
On the phone.
Galaxy S2, is it?
Feel free to pass it around.
Yeah. If you press skip in the corner, you can play just the typical thumb playable.
And here's the game in Chrome.
Still loading a bit.
Yeah.
Yeah. There
you
we
just
are.
hit F11 and you're full screen. This is in a browser, by the way.
Your phone is now disappearing.
That's a demo.
This is just to prove that this is not just smoke and mirrors. It actually works. We actually built the real-time Studio Lite IDE that you saw inside of Uno. So it's very meta.
No, we are building the next version of real-time Studio inside Uno.
I am ahead of myself. We are building the next version, but you don't get to see it yet.
Back to PowerPoint. It's just a few more things we want to share with you. We were here and come on.
This is why I use a Mac.
I do use a Mac.
Not with the proper OS you are. Okay, so that was a demo, but the important thing and the reason why we're here, because we've shown this at GDC, we've shown it at a few closed events with some industry partners as well. We are looking for any one of you who want to actually do something with this. So we are announcing the pilot program. And that can be a company, it can be a team of people, it can be you as a single developer, but we're looking for sort of 5 entities, if you will.
With cool projects.
With cool projects, we will do a pre-selection, so you can contact us and say, we want to do, I have a cool idea for a tree I want to do in WebGL. And I said, no, not you guys again. You'll only end up making it like a fractal broccoli thing. But we will get you early access to both the language and the Real-Time Studio IDE. We will give you support, which means you can contact us, you can contact him directly. No middlemen, no one in Bangalore, India to help you. Everybody is in Trondheim or Oslo and will be helping you get your project up and running, because we want to see what you can do with this. And you will get the actual way to, you can come in and say that the way you did this was absolute bollocks, it's stupid, don't do that. And we will say, you're right, we will change it. And you will have changed the project. So we win some, you win some as well.
That's why we have to limit it to a quite low number, because we're going to do quite good follow-up and support on these guys to make sure their projects actually get done. If you need a new feature in the language in order to get what you need to get done, then we will prioritize that. And because we need to build a portfolio of things to show that this can actually be, and to prove to ourselves, and maybe we need to change something, because we're going to make the language that you can actually use for all your graphics needs.
Yeah, that's the goal. It started out as madness, but after a few years, it turns out that it might actually be possible. But the language and a way to do things is no good if nobody uses it. So we want 5 teams, 5 projects, to come to us and just say, I want to do this, or I'm working on that for a client or whatever. And we say, cool, you're one of the guys, you can do it, and we will support you. So I don't think we should linger any further.
Nope.
I think
we will be here at assembly through to Sunday afternoon.
So you can look it up. You can email Anders.
And
or
if anyone
me.
wants a card with the contact information, you can just come up here right now.
And we want to thank you for your time and hope you enjoyed it. Thank you.